video, we're going to take a quick introductory look at what's known as a quadratic function. It's a new type of a function that we haven't studied yet this year. And a quadratic function is one that is in the form of y equals ax squared plus bx plus c. We call it quadratic because the highest power on the independent variable x is 2. So anytime the highest power that you have in your function is a square, you have what's known as a quadratic function. And in general, a quadratic function is graphed as a U-shaped graph called a parabola. And I want to talk about some of the parts of this type of a graph. So this whole graph here, we call that a parabola. And there are a lot of important parts of a parabola that we're going to learn about. So the first one is either the low point or the high point. That point on the parabola is called the vertex. And that's an ordered pair x, y. Notice how this parabola is it's symmetric. It's basically just a U shape, and this axis here sort of acts like a mirror. We call this the axis of symmetry. And that's basically a sort of an imaginary line that cuts this parabola in half, and it's perfectly symmetric around that line. A parabola will always intersect the x or the y-axis somewhere, and that is called the y-intercept. And sometimes a parabola will intersect the x-axis as well, and those 2 points are called roots or zeros. So those are really the main parts of a parabola that you need to know. You need to know the vertex is the lower high point, and that form of that is an xy ordered pair. The axis of symmetry is an imaginary line that cuts the parabola in half. The form on that is the equation of a vertical line, so x equals some number, whatever that x value is. Wherever the parabola crosses the y-axis, it's called the y-intercept. And wherever it crosses the x-axis, if it does, those are called roots, or sometimes called zeros. Now what I want to focus on in this video are taking a look at how a couple of these values are going to change the shape of a parabola. So I'm going to take a look at what A does and take a look at what C does, and we'll take a look at B another time. So the first thing I want to do here is take out the old graphing calculator and just take a look at what the most basic quadratic function would be, y equals x squared. So if we graph that, we get a parabola that is kind of known as the parent function, because all other parabolas that we can make are really just a transformation of this parabola. This is y equals x squared. Now the first thing I want to do is see what happens when we increase that value of a. So right now it's 1x squared. And I want to see what happens when we increase that. So maybe 1.5x squared, and then maybe 2x squared, and then maybe 3x squared, and then maybe 5x squared. So if we graph those, we'll see what happens when you increase the value of whatever is in front of the coefficient of x squared, what we refer to as a. So there's 1.5x, there's 2x, there's 3x, there's 5x. So what's happening here is as a got larger, that parabola got more and more narrow. I want to go back and see what happens when we make those smaller. So maybe instead of 1x, let's say 0.75x squared, and 0.5x squared, and 0.25x squared. If we graph those, well, here's the first one, the parent graph. Here's 0.75x squared, here's 0.5x squared, here's 0.25. As that value of a gets closer to 0, the parabola gets wider and wider. Take a look at what happens when we throw in some negative values. So here's x squared compared to negative x squared. So there's x squared, and negative x squared is now upside down. So anytime we have a negative value of a, we have a parabola that is opening downward. Anytime a is positive, that parabola opens upward. Let's take a look at what happens when we change c. So right now, we sort of have a value of c that is just 0. It's just x squared plus 0, I suppose. Let's see what happens when we have x squared plus 1, and x squared plus 2, or x squared plus 5. So here's y equals x squared, the parent function. There's plus 1, there's plus 2, and plus 5 is a little bit off my graph. So what's happening here is whenever you are increasing this value of c, you are shifting the graph upwards. See what happens when we do some subtraction. So let's say x squared minus 1, and x squared minus 2, and x squared minus 3. So there's a parent function, y equals x squared. Here's minus 1, shifted it down. X minus 2, shifted it down. X minus 3, shifted down. So anytime you're decreasing that value of c, you're shifting that down.